error probability of qpsk. Here in the error probability of the qpsk, we are consider this is an, that's the probability correct decision takes place. Consider this is a x1, this is an x2 direction. Here these are the four regions, that is z1, z2, z3 and z4. Consider this is an correct decision and this region is an incorrect decision. That is, here x varies between 0 to infinity x1 and x2 varies between 0 to infinity. And in the qpsk system, an operating of an additive white Gaussian noise channel, that is whatever we are transmitted at the receiver side, here we will receive the original signal with some noise. So ISI of t plus W of t, where here t varies between 0 to t and I varies between I is equals to 1, 2, 3, 4, because we are using the four phase of carriers. So where W of t is the sample function of the white Gaussian noise process of the zero mean, that is the noise here W of t, and here you consider the variance of the power spectral density is equals to n0 by 2. This is a standard, that is the variance of the power spectral density is equals to n0 by 2. So here we are using the two correlators we are using, that is for x1 we will get an 0 to t into x of t original signal. This x of t is multiplied with the phi 1 of t, that is integral of x of t into phi 1 of t into dt. So same we are written here, that is x1 of is equals to 0 to t x of t into phi 1 of t into dt, where this as we know that this is an phi 1 of t is equals to the phi 1 of t, as we know, that is phi 1 of t is equals to 2 by t cos 2 by fc of t. So comparing this here, consider this value. So we are writing square root of 2 into cos 2i minus 1 by pi by 4 plus w1. This is an noise. W1 is the noise. So this equation we are written as plus or minus square root of e by 2 plus omega 1, and this x2 can be written as same 0 to t x of t into phi 2 of t, because we are using the second one here. Using x2, that is second. For x2 we are using phi 2 of t. So here for in phi 2 of t, this signal we are writing here, that is square root of 2 into square root of e into sine 2i minus 1 by pi by 4 plus w2, here plus or minus square root of e by 2 plus omega 2. Not omega, this is w2, that is 1 is w1 is 1 noise, other one w2 is also another noise. Consider the probability of correct decision place is equal to the product of the conditional probabilities, that is x1 is greater than 0 comma x2 is greater than 0. That means x1 lies between 0 to infinity and x2 also lies between 0 to infinity. Therefore we are written in the correct probability decision, that is pc is equals to 0 to infinity f of x1, 0 to infinity f of x1, f of x1 is given by the x1 by s4 of t into dx1 into integral of 0 to infinity f of x2 into that is small letter capital letter x2 into small letter of x2 by s4 of t into dx2. This means this is an f1 of function x1 by s4 of t. This signal also is transmitted, and other two signals. Consider here we are considering the 2 bits, no? So the bits. So this and this we are transmitting, that is x1 of t s4 of t and s1 of x2 of t into s4 of t. This figure. this. And if we are done by using, we can write here that is p of x1 is greater than 0 and p2 of p of x2 is greater than 0. X1 and x2 both are greater than 0. So these two are transmitted. Substitution in the, that is PC. Substitution in the PC, this 0 to infinity, this we can return in by the probability density function. So 0 to infinity 1 by square root of pi n naught, this is the standard, into e to the power of minus here x1 is transmitted, so x1 minus here for an S4 of t, that is for message signal S4 of t, the value is the minus square root of e by 2 by square root of n naught. This is the standard. So whole square into dx1 into integral of 0 to infinity 1 by square root of pi n naught into e to the power of minus x2 minus square root of here eb by 2 square root of n naught into this whole square into dx2. That is, this is one function and this is one bit function. These two are 2 bits function, and here consider the z is equals to this value x1 minus square root of e by 2 by square root of n naught, and for this we are considering that z is equals to x2 minus square root of e by 2, so square root of n naught. Here differentiate with respect to z, that is dx is equals to, we differentiate with respect to z, the value will get dx1 by square root of n naught, and here with respect to dz we measure square dx2 by square root of n naught. That is, when x1 tends to infinity means the z also tends to infinity, and when x1 tends to 0 means the value will get, that is minus square root of e by 2 by square root of n. So this is general, that is minus square root of e by 2 n naught. So substitute these integral values in the above equation. This equation we will get, that is here 0 changes from here, that is minus square root of e by 2 n naught to infinity. So 1 by pi, because here in the n naught, this n naught and this n naught it cancel, okay, not cancel here. This consider this is in z now, so we are written as a e power of minus z. This is in z, so square is there, so we are written in the minus z square into dz into integral of same here also it changes, that is minus square root of e by 2 n naught into integral z infinity and 1 by square root of pi into e to the power of minus z square by dz. So multiplying these two we will get that is, take 1 by square root of pi outside the integral, so remaining is the minus square root of e by 2 e naught 2 into n naught into to infinity, so e into z square, this is 2 terms, so we are multiplying the square, and this 1 by pi integral of minus square root of e by 2 e naught in infinity into ez square into dz is equals to 1 minus 1 by 2 erfc into square root of e by 2. This is a standard function, that is we are written in the, this form is in the form of this erfc function. Okay, this we are substituting, this is an error function, complementary error function. This is erfc is a complementary error function, and that is substituting this to the above equation, we will get therefore PC is equals to 1 minus, same here, 1 minus 1 by 2 erfc into square root of e by 2. So same thing we are written here, this 1 minus 1 by 2 into erfc to square root of e by 2 n naught into whole square, because here we are considering the square, so whole square. So error function, complementary error function of in u is equals to 2 into q into square root of 2u. This is nothing but an 1 by 2 error function e by 2 n naught. This can be written as, that is, in terms of this, that 2 into 2 already it is a 2 by here 2 into square root of q into square root of 2 into here. This is, and u is nothing but, here by looking these two, u is nothing but a square root of e by 2 e naught, 2 n naught. So same thing we have written here. There 2 cancels, so remaining term is nothing but, and here also square root to get cancelled. So q into square root of e by e naught. So therefore the pc is equals to 1 minus q square root of e by e naught into whole square. So split this, it's in the form of a minus b whole square. So pc is equals to 1 square minus 2 into q square root of e by n naught in plus q square into square root of 2 by n naught. Here the average probability of a symbol error of a qpsk is given in terms of the, that is PE, total, the average probability is given 1 minus PC. Here in the 1 already is there, 1 minus PC. Here substitution, this is nothing but minus PC, so plus is there, so minus, because of this we are multiplying the minus, so minus 1. Here plus is there, so minus into minus plus, plus 2q square root of e by n naught, and here minus is there, minus into minus, this is the minus signal. So this is a minus q square by square root of e by a naught. So 1 get cancels. The remaining terms are 2 into 2q square root of e by n naught and minus q square root of e by n naught. Here neglecting e by n naught square is less than 1, so this term we are neglecting. The remaining terms is the q 2 into q e by n naught. Here in the qpsk signal, the transmitted energy signal is that the twice that of an energy per bit, that is e is equals to 2 eb here. So 2 eb or is equals to 2 tb. So PE is equals to 2 into q. Here E is written as an 2 EB by N naught. Here the bit error rate of the QPSK is given by n q into square root of 2 EB by N naught into whole square, with gray coded using the incoming binary signal.